Welcome to this IT Explainer video, part of our integration topic range. In this video, we'll cover the subject of CGI within SLM. This technical overview will cover the installation and usage of the SLM Cloud Gateway interface. The CGI is a background service that is created to provide data integration service between a variety of historical data sources and the SLM, the Safety Lifecycle Manager. It has three primary functions: to pull data, to process data, and to send data. The following information will be covered in this training: CGI overview, web development, configuration, CGI workflow, configure historian tags in SLM, configuration for SLM, polling historian data, processing data, sending data to SLM, testing functions, data exports, logging and debugging, and maintenance. In Chapter 1, we'll be covering what is CGI, how does CGI work, and technologies used. CGI is an application which provides data integration between multiple sources of plant process data and SLM. Data sources can be from OPC servers, data historians, relational databases, or FTP files. CGI gathers data and looks for events within the raw data based on pre-configured conditions set by SLM for each data point. If a data point matches the required value and condition, an event record is created and sent to SLM via the SLM API. CGI is built in ASP.NET Core Platform, so will run on Windows or Linux operating systems. It can run within the Azure Cloud container or locally within a Docker container environment. Communications between CGI and SLM is accomplished through RESTful API. Communication between CGI and the data source is through OPC, Web API, and WebSockets. Multiple plugins have been developed to accommodate the variety of data sources. In Chapter 2, we'll cover creating an Azure instance, deploying from Visual Studio, setting up a database via FTP, and running the application. To create a CGI instance on Azure Portal, we'll go to App Services, Create, Web App, pick our resource, we give it an application name, SLM-CGI-demo. Pick how we publish: code, Docker container, or static web app. We choose .NET 6 as our deployment on Linux. We'll choose South Central US as the region. Our pricing plan is free for now. Review and click Create. It's now completed successfully. Go to your resource, which shows your application. There's the address for it. Right there. Just waiting for your code. Let's now download the profile. Save it somewhere where you can easily find it. Go to Visual Studio. Create a new profile. Import the profile. Under Download, click the profile that you've downloaded. When you've finished, it should be in your profile list. We'll do the demo using zip deploy. Hit Publish. Once published, you'll bring up your website. The CGI runs on a local database, so it'd have to be FTP'd to the website before it actually works. To get your credentials in Azure, you go to the Deployment Center, FTP Credentials. After you record that information, you can create a profile Under your favorite FTP client, I'm using FileZilla. Enter the information and click connect. There should be a folder called data. If there's not, you need to create one. And then copy your CGI data SQLite file to that directory. Your CGI application runs on Azure. So you can go to the portal and you see the default domain right here. You click on it. Okay, that's started. You can go back to your portal and stop and restart the website anytime. The application on the main page has status or logs. It also has the Hangfire dashboard where it will run all the background processes. So recurring jobs or any current jobs will be listed in here. On the top menu, you have your EDA configuration. So these are the configurations in your SLM history. Your data engine, this is where it gets the data from Pi or some other sources. Your events, these are the events that are found, for example, trips and bypasses. The logs menu contains your logs for any kind of debugging errors. Process logs are actually the logs for all of the data that's being pulled from Pi and so on. So if there's any issues, you can see it here. Setting will allow you to see all of your settings. You can create new ones if needed. Swaggers for testing. So this is for the API testing, getting to each of the actual calls directly. The login is required for any kind of changes that you want to make. For view only, you don't need to log in. In Chapter 3, we will cover application settings and plugin settings. The web-based CGI has some settings that need to be configured for each client. The first authentication type we see here is bearer token. So depending on the type, you'd set the auth ID or auth security, also which URL and if you need to grab any authentication. The CGI URL is a reporting application API. This doesn't need to be changed. Cleanup data is true, means any temporary data will be deleted. Cleanup minimum, so it would only start the data cleanup at a minimum of 1000 records. Customer ID, this would identify the customer CGI ID for reporting purposes. Debug typically is turned off. When you turn it on, it would actually create a debug file to see if you have any issues. Email to, this is the email that all errors are sent to. For error wait, this is a pause, is typically set to false. Instance name, this is for the reporting so that you can tell which log it's for. Keep logs is how many logs before it starts deleting them. Key name and key value, this is for the authentication above here, depending on the type. Bear token will use the key name and the key value. Last runtime gives you an idea when the data polling last run. So microprocessing when turned on processes the data after each call. The offset is during polling. It would take today's date and time and it goes back historically on that offset. So if it's a 24-hour offset, it means you'll gather data up until yesterday. This is to prevent you from grabbing today's data since it could change. For some sites, it doesn't change. For some sites, it will change because the data has a delay, so you might not be getting any data back. Offset from UTC, this is based on what time zone you're in. So this lets the software know that you're -6 or +6 hours from UTC. This password is for authentication on some data sources that require a username and password. This is the name of the plugin that it should load. So we have different types of plugin, and this is where you'll tell the system which plugins to load. Poll tags, with this being true, it will start polling. If it's false, then the system will not poll for tags. Some sources don't have tags, so this will be set to false. Save bad tags. So when the system is pulling tags from SLM, it will either save the bad tags, which are basically tags that are not completely filled out or missing properties or so on. Scan interval. This shows in minutes, so every 60 minutes it will scan for data. Scan type, either historical or live data. Send to SLM. After an event is found, it will leave a buffer until someone manually sends it, or it automatically sends it. Turn to true, will automatically send it. Server time zone. This is if the server is not in the same time zone as the data source. so typically it will be 0. This is just timeout. This is for SLM timeout. So once it gets an event, it will connect to SLM and create an event. It's 120 seconds for the timeout, so 2 minutes. The SLM key, this is the API key. The SLM URL, this is the API address for each instance. The source, for example, let's say Pi is the source, and you've got a Pi server name, and then a source list essentially goes behind the original source. So once you hit the server, it will go through each of these sub-addresses. Tag filter, this is used for filtering tags. If there are certain tags that are only used to look at data coming from SLM, you can put a filter on. If not, just leave it blank. Username that goes with the password above. So some systems require a username and password. In Chapter 4, we will cover polling data, processing data, and sending data. The first portion of the workflow is the data collection. So we collect data from any type of historian, either a Pi data source, an OBC, HDA, or some type of a file repository. Once the data is collected, it will begin being processed. It is looking for either a change in event or any kind of status inside the tag to show that an event has occurred. Once it sees that event, it will create a record, a temporary buffer that holds the record of events. Those events are then sent after it's being processed or will be sent as part of a cycle. The data event that's found will be sent to SLM API. The API gives us an interface to create the events within the SLM instance in the database. In Chapter 5, we'll be covering bypass events configuration, demand events configuration, fault event configuration, and pulling configuration from SLM to CGI. To configure the events for your CIF, first pick the CIF that you're going to configure. Go to the Historian tab. You need to first enable the events that you want to configure. So here we're going to enable all 3. Hit save, and now they should all be enabled. You can add the events manually, or a quick way is to synchronize all of the components. This will add all the events for you. Once the events are added, you can enable them. So here's a bypass event. We can add any server configuration, so point to the name of the server. If not, you can leave it blank. Enter the tag name for that particular event. Enter the compare value. So if the value is equal to 1, it will be activated. If it's equal to 0, it will reset. Hit save. For a demand event, it's the same. Enable the demand. Configuration use is an event. Server, if you have one. If not, leave it blank. Then enter the tag name. Enter equals for the compare and a value of 1. There's no reset for activation tags, so just click on save. For a fault, if there's not a component, it obviously won't bring it in, but you can add one manually. Let's give it a component name. Click enable, same as a bypass. Let's enter the tag name. Give it a compare value and an activation value, a compare value and a reset value, and hit save. That should all be set up now. So if we come back to the CGI service page, the SLM configuration that's being used by CGI is under this menu called EDA config. If you click browse, it will bring up all the existing tags that are in the system that we pulled from the SLM API. To refresh, you can click on retrieve config here, which will run in the foreground. Or you can go to the Swagger sample and perform a get command from here. In Chapter 6, we'll be covering getConfig call to API, configuration format, and how it is used. The CGI configuration is available via the API on your SLM instance. By using the Postman software, we can see how it actually works. So the command is a get command, server name /API, CGI config, variable offset tells you the starting point, and the limit is how much to pull. When you hit send, it will send the command. When the data comes back, you'll have a status 200 showing all is well. Then here's your data payload. It's a JSON format. So the first item is the name of the actual configuration of the bypass. So this is a bypass. The event type down here tells you it's a bypass. The date time is the time of polling. Application object reference. This is the reference of the CIF hashtag. The primary tag is also the same as the event tags. This is used for a different purpose. So the one we'll be using is the event tag. It has the tag name, the EQ for equal as the event operator. The comparison value is 1. So if we see a 1, we'll recognize it as an event of bypass. Also, the configuration is enabled. Let's look at this one. This one is a bypass reset. It has RST in the name, but also the type. The event type is 11, and the same for the other application reference. The only difference is the comparison value. So same tag, except we are saying this is equal to 0. So the way all this is used is it compares each process tag that gets from, let's say, your historian, such as Pi, that compares that tag name to this one. If there's a match, then it uses the value of that tag and then compares to see which one it equals, either a 1 or a 0. The comparison is only during the change from 1 to 0 and 0 to 1. The event is not created if the value remains a constant 0 or a constant 1. It's only during a change. In Chapter 7, we'll be covering different source types, data protocols, data security, and the plugins that are available. The Pi Web API, OPC Classic, OPC UA, and file passing. So one type of data storage is from a historian. That historian could be, let's say, a Pi server, or it could be an OPC server that also stores historical data. The other type is live data. So live data can be pulled from OPC server or Modbus or any other source from the plant. The sources would then determine which data protocol will be in use. So the data protocol is between this section and this section here. The protocol could be just plain text, encrypted text, or any other type of binary communication. The protocol on this end is plain HTTP text that's under secure SSL. For data security, there should be a firewall between your data source and your CGI. If it's on the web, the security is a lot less, but otherwise your data source will be on the control network or the enterprise business network. Your CGI could sit somewhere on the DMZ, or it could actually sit outside. The firewall here between the CGI and the SLM API only exists if the CGI is sitting on the customer's internal local area network. If they're both on the web, then there is no firewall. Now for the plugins that we have in the CGI to handle all of these different sources, we have a PiWare API plugin. We have two types of OBC plugin for Classic and UA. We can do file passing, and then we can also do OPC Classic Live. If there is file passing, it will require FTP transfer or some type of data dump to a folder. In Chapter 8, we'll be covering SLM API for events, data payload, and response types, success, warnings, and errors. So if we look at the sending of events to the API from the CGI in detail, so it will be this section down here. So in this example, we can show the Postman software using the function to send bypasses. So the URL will show that the endpoint is a CGI event on your API for your instance. In the body, you would need the process event name. You'd need the application object reference, which is the hash ID for that CIF. The type of event here is a 10, which is a bypass. The primary tag, which is not necessary but optional. The event operator and the event compare, that's also optional. The timestamp when the event happened, that is required. We hit send, we get a response. The status is 200, which means it's good. You can also see it here. The response code for it, saying that it's been successfully run. Shows the activation date, where it came from, which is the CGI. How long it's been in bypass. That number is also based on the reset. In Chapter 9, we'll be covering general logs, error logs, debug logs, and process logs. The CGI has a set of logging functions to help you troubleshoot any issues. For example, on this front page here, you'll see the current log that just came in. So this is just a quick overview. To get a better look, you can go to logs and then all. This will show you all the logs that have occurred. Or you can filter. So these are informational logs only, error logs only, and debug will show every log, every step that occurred in the system as part of a debug. You can also go to the process logs. This will show the logs for the polling of data. So any polling issues would show up in here. In Chapter 10, we'll be covering temp data, logs, and event lists. So the CGI has a lot of built-in features for maintaining items like temporary data and logs and events. So first, we can look at the settings themselves. If you want temp data automatically cleaned up, you would set this to true, and this is how many records before it would start cleaning up. So it would need to hit 1,000 records before it will start cleaning up. So also in the logs, if you don't want too many logs in the system, turn this off. Setting debug to true is going to create a lot of logs. So here we have the same thing for the logs. Just like in cleanup data, we have a log minimum. You can't turn off the cleanup log because it generates so many logs. Here you can set how many logs you can keep. Right here it sets 10,000. The other way to clean up the logs is in here. You can delete all logs. For example, right now we have these logs. We'll delete those logs. So now all the logs have been deleted, but of course it's a running system, so new logs have just come in, but there's only 81 in there right now. You can also delete the process logs. So these are your process logs. Click delete process logs. That's now empty and it's not actively collecting data at this minute. We can see the regular log has already gone up to 365. This is just because of the debugging.